Hello, my name's Ray Aslin. I'm a Fortinet trainer. I teach a course called Public Cloud Security, and within that course, we have a series of labs on Amazon Web Services and deploying FortiGates and FortiWebs in Amazon Web Services. And we have a series of labs on Microsoft Azure, deploying FortiGates and FortiWebs on Microsoft Azure. For the self-paced version of this course, I'll be doing a series of recordings using the AWS labs and demonstrating those labs, and using the Microsoft Azure labs and doing those labs. This particular recording is the first in the series of Microsoft Azure labs. There are a total of 5 labs that we'll be going over together. In this first lab, we're just going to do a very basic topology, and I'll go over that in just a moment. You do not need to watch the AWS videos, the Amazon Web Service Lab videos, before the Microsoft Azure videos, and you do not need to watch the Azure videos before the AWS videos. I will try to make them as independent as possible. It is somewhat difficult not to talk about them and make direct comparisons. As I go through things on Azure, it's very difficult not to say, well, if you're familiar with AWS, this is sort of like this other competing technology in AWS. As an example, Azure virtual networks are very similar to VPC or virtual private clouds in AWS. They have a lot of similar capabilities and they solve a lot of the same types of problems. So you may hear me do that from time to time, but please make no mistake, that does not mean that you need to stop watching this video and go watch the AWS video. I'm sure that some of you who are watching these videos will simply opt to only watch the video for the cloud service provider that you're using. If you're an Azure customer, you'll probably focus on the Azure videos. If you're an AWS customer, you'll focus on the AWS videos. But if you would like the complete training experience, you should go ahead and watch all videos. Now, within the Azure or AWS videos, I would watch the videos in order. The first video that I do is usually lab number 1 and lab number 2. And in this case with Microsoft Azure, I will probably try to do lab number 1 and lab number 2 in one video. Depending upon the amount of time that takes, I might also include lab number 3 in the first video, but usually at least lab 1 and lab 2. And then I will do a video with lab 3, a video with lab 4, a video with lab 5. And I would watch them in that order. Now, I know some of you will want to try to perform these lab steps that I demonstrate using your own Microsoft Azure accounts. You absolutely can do that. A lot of times it's helpful to watch the video once and just kind of get a feeling for the overall steps, and then go back and follow me through the lab. The one word of warning that I will give you is one of the most important things that you need to know to do if you perform the lab yourself is to delete what you have created. What we implement in the lab will introduce cost to your Microsoft Azure account. So you'll want to go back and delete the objects that we've created after the fact. With Microsoft Azure, that's actually quite simple to do. And the first time we delete resources in the Microsoft Azure labs will actually be after Lab 3. At the end of Lab 1, I will take the resources that I've created in Lab 1 and use them for Lab 2. And at the end of Lab 2, I'll take the resources that I used in Lab 1 and 2 and use them in Lab 3. So you won't actually find me demonstrating any of the deletion until the end of Lab 3, because all of those resources will be used in Lab 3. Well, I think it's time to go ahead and get started. As I go through these labs, there is a lab guide in the full version of the course, and I will refer to the topology diagrams for the individual labs as we go through the course. I'm a visual learner, and I think a lot of people appreciate having a diagram to be able to refer back to. So I will go ahead and talk about this diagram, perhaps draw through it, and then we'll go into the console and deploy what we see in the diagram. So on that note, let's go to the Azure Lab Guide. I've got the PDF here. Let's go take a look at the elements that we're going to deploy. Let me give myself a pen to draw with. And we'll just choose a pen color, and we'll choose red. Since the print there is blue, we'll choose red. As part of this lab, we're going to deploy an Azure virtual network in a region. We're going to use the central US region, and we'll deploy a VNet using the 10.0/16 CIDR, the 10.0/16 address space. Within that VNet, we will deploy two subnets. One subnet, which will be a public subnet, we'll use the 10.0.0/24 address space, and then another subnet, we'll refer to it as the inside or the private subnet, we'll use the 10.0.10 address space. So here we have two subnets within a single VNet. We will configure and deploy a FortiGate that plugs into both subnets. Let's choose a different pen color. Here we go. Well, that's actually blue is already being used, so let's choose black. So this gray icon that we see here, that's our FortiGate. And our FortiGate is going to have two virtual network interfaces, two virtual NICs. By the way, if you have watched the AWS videos, you may find that there's a lot of concepts that are similar to AWS, and the names of the resources or the concepts are slightly different. I made mention earlier, virtual networks or VNets are similar to VPCs. Virtual NICs are similar to elastic network interfaces from AWS. So here we have two virtual NICs, one virtual NIC plugged into each subnet. Now, I've made my drawing a little bit messy there. Let me clear that up a little bit so we can draw again. The VNIC that plugs into the public subnet will use 10.0.0.4. The VNIC that plugs into the private subnet, will use 10.0.1.4. Why .4? Well, .4 is the first available IP address on this subnet. Anytime you create a subnet, whether you're in AWS or Azure for that matter, the first three IP addresses of the subnet are not available for you to configure objects to use. The .1 IP address, or the first IP address of a subnet, is an intrinsic router, a built-in router built into the cloud provider. The second IP address of a subnet is used as a DNS server within that subnet. And then the third one is reserved. So RES. By the way, if this is the first of the videos that you've ever seen me do, you will get used to the fact that I have what I like to refer to as IT handwriting. I type for a living, so once I start writing fast, I really lose my handwriting. And let's say that was supposed to be router. And if you're thinking, wow, Ray, you draw like a toddler, you're right. I'm not an artist. I'm a pretty decent IT engineer, but I'm not a very good artist. So I apologize for some of the crudeness of my diagrams, but I hope it still helps you understand what we're going to go and accomplish. So in addition of deploying this FortiGate and giving it two interfaces, the .4 IP address within each of its subnets, when we are done, we'll also have a public IP address. This public IP address will be associated with this network interface inside of the public subnet. So if someone sends something to this public IP address, Azure is going to forward it to the public interface on the FortiGate. And then within that public interface, we will configure a VIP. So the FortiGate will only be aware of the 10.0.0.4 IP address, the 10.0.0.4 IP, which is what will be on this VIP. And the VIP will be used in a firewall policy to pass RDP traffic to a Windows system on the inside network, on the inside subnet. This public IP that we see here, this is a configurational resource within Microsoft Azure. Its job is to destination NAT, that's DNAT. Anything that we get sent to this public IP gets destination NATed to the 10.0.0.4 IP address on the FortiGate. When the Windows Server replies, let's erase some of my ink here and use a different color. We'll do this in green. When the Windows Server replies, the Windows Server reply will go through the FortiGate. The FortiGate will process it back through policy. The policy will then source NAT that back to 10.0.0.4, which will forward out of Azure and get source NATed back to that public IP address. And really all I want to point out here is very similar to AWS, the FortiGate deployed within the virtual network has no visibility to the public IP that is sitting in front of it. Everything that it sees has to do with its own port 1 IP. This is its visibility. Now it does see the original source IP that sent it something. Let's say that someone is trying to RDP to the public IP address. changing pen color here. Someone RDPs to that public IP address. The public IP gets destination added to 10.0.0.4. The original source IP that actually sent that RDP, that tried to initiate that RDP session, that is visible. 166.3.2.1. We'll just say that was the source IP address that tried to initiate that RDP. And when we create this firewall policy for the VIP that sends the traffic to this Windows server running inside of Azure, we won't do any source natting. So the actual Windows server will see a source IP address of 166.3.2.1. When it sends its reply will get forwarded to the FortiGate. Now, how or why will that occur? There are going to be some routing tables in here. There's going to be a route table associated with this inside subnet. In this routing table, we'll have an entry that says 000/0, go to, and it will use the inside IP address of this FortiGate as the next hop, as the way to get out. So this will allow any replies that come out of the Windows server going back to 166.3.2.1 to go to the FortiGate. Now, as the FortiGate processes traffic and sends it outbound, the FortiGate's next hop IP address will be the intrinsic router on the public subnet. So within the FortiGate, inside of the FortiGate, there's a default route that says 000/0, go to 10.0.0.1, which is this intrinsic router built into the Azure VNet in the public subnet. We'll process firewall policy. Hopefully we will pass firewall policy and we will send the response back to 10.0.0.1, and that's what gets it destined, that's what gets it source natted back to whatever that public IP was. There we go. So we've gone through a little bit of diagramming. We may reference back to this diagram a couple of times as we go through lab number 1, but I think it's a good time for us to go ahead and start on lab number 1. I'm going to erase all of our ink here, erase all the drawings, give myself a regular mouse pointer again, yep, and we'll minimize down. I'm logged into my Azure console, my Azure dashboard already, so we can go directly into beginning our deployment. Let's put this out of the way. I didn't mean to maximize that back. So let's go start that process. I'm going to go to the 3-line menu icon on the left side, and I'm just going to start off with creating a resource. This is going to come up with a button where I can search the Azure Marketplace for what kind of resource I want to create. And I would like to create a, well, there you go. It's actually in my history of search. I do perform these labs somewhat often, so my browser will commonly prompt me with things that I have typed before, just for the sake of it, so we see all of the options. Let's just search for FortiGate and see what comes up. Here we go. We have several items in the Microsoft Azure Marketplace. If we look through here, we're going to find bring your own license and pay-as-you-go options for FortiGate, FortiWeb, as well as many other Fortinet products. For this very first deployment, it's a good place to start. Let's use a deployment that uses an ARM template. ARM templates are templates that include all of the resources that we might need to support a solution. So instead of simply deploying a FortiGate, which is something that we could do, it will deploy a FortiGate and a VNet and 2 subnets. It'll deploy multiple parts that we need to be able to support this. It'll also deploy a public IP address. It will create subnet routing table entries for us. If I simply wanted to deploy a FortiGate, a pay-as-you-go FortiGate, I could use this one, Fortinet FortiGate Next Gen Firewall. But since I want the version with the ARM template, I'll choose this FortiGate Next Gen Firewall single VM with ARM template. Now you see this single VM with ARM template, and you might think, wow, why is there a version of this that just says single VM? Well, there's another version of this that says FortiGate Next Gen Firewall for Azure Load Balancer HA. and this deploys multiple FortiGates behind a load balancer. So that's why there's a single VM version, because there's a version of this that is more than a single FortiGate. We're going to start off with a simple topology, single FortiGate. So we click on it and we choose it, and it'll come up and offer us some information about it. There's some plans in here, some costing information. I don't plan on running this very long, so I'm not too worried about the price. Let's go ahead and choose Create. Once I choose Create, it'll begin to ask me for some options. So when we create resources, those resources in Microsoft Azure have to go into a resource group. In this case, I'm going to use an ARM template that's embedded with this deployment, and everything in the ARM template will go within this resource group. Let's go ahead and create the new group. I'm just going to call this NSE7 Lab. As much as possible, I'm trying to match the experience of taking the full class, where you attend class, you have lecture, and then I have you perform these labs. I give you a lab guide and you perform them. So I'm gonna use some of the same names that are used in the lab guide. Very good. So we'll call it the NSE7 Lab resource group. Let's go ahead and deploy into Central US. There we go, Central US. The FortiGate instance name can be SXFGT Lab1 for which version. Since this is written for a particular version of the course, I'm going to use the version of FortiOS for that version of the course. And right now, that would mean choosing the latest pay-as-you-go 6.2 version, which is 624. We are going to do pay-as-you-go rather than the bring your own license. If you use the bring your own license option, you have to upload a license file after the FortiGate boots up. If you've ever licensed a virtual machine on-prem, it's a very similar process. You go to our website, you log on, you have a license, you get a license, you register it, you get a license file, and then you upload that into the VM. But we'll be choosing pay-as-you-go, so as soon as the VM boots up, it will be licensed. Admin username, we'll use FortiAdmin. Password, well, I'll choose a password. Here we are. Just take a quick look at this. Central US, FortiGate Lab1, 624. That all seems appropriate to me. So let's go to next, network settings and instance type. Now, it is noteworthy that I can click around to other screens by going on the top, or I can just hit next. Since I do want to visit all of these screens, it just makes sense to go ahead and hit next. Now, this ARM template will create a VNet for me. And as I wait here, I'm waiting for it to, there we go. I'm waiting for it to decide what the name of the VNet is that's included in the ARM template. The name of the VNet deployed is called FortiGate Protected VNet, and it's going to create two subnets for me, one that is referring to as an outside subnet and an inside subnet. If you are simply deploying a FortiGate without the ARM template, it will not create this VNet for you. You might have to create it right there in that moment if you haven't already created it. I do want it. FortiGate Protected VNet, public facing subnet 10.0.0/24, inside subnet 10.0.1/24. I'm comfortable with both. I don't need the accelerated network option. And I don't need an F4S. I can do with something a bit smaller, which should save me a little bit of money considering this is a lab. I'm gonna search for an F1S. Here we go. So one CPU, yeah, there we go. One CPU, 2 gigs of RAM. For lab purposes, that is more than enough. So we'll hit next, FortiGate IP address assignment. And we are going to create a public IP address. So we'll hit create new. Let's call this SX-public IP-FortiGate. If you have already taken the AWS videos, I would say the easiest equivalent to think of this as is what an elastic IP is. So a public IP is it's a public IP address from a pool of IP addresses that Azure owns. that is used externally of the VNet to allow traffic inbound towards your instances. And when you assign them to an instance or to a virtual NIC, when those virtual NICs talk outbound, they get source NATed to that. So it's a one-to-one relationship with a resource. This public IP address will have a one-to-one relationship with the FortiGate. But once that traffic reaches the FortiGate, we can use things like a VIP and allow access to inbound resources, or we can use this as traffic leaves the FortiGate and we could have multiple devices use it for outbound access to the internet. There are two types of public IP addresses: basic public IP addresses and standard public IP addresses. Basic public IP addresses can be dynamic or static. And what we mean by that is what happens when the VM gets turned off. If this is set to dynamic and you shut the VM down and turn it back on, it might have a different public IP. If we set it to standard, it won't ask us that question. All standard public IPs are always static. So there's simply no option one way or the other. It's going to be a static public IP. The real difference between basic and standard isn't whether or not you can choose dynamic. That is a difference, but that's not the core difference. The core difference is a standard public IP can be redundant within multiple availability zones. And that a little bit later, we will talk about load balancers in Microsoft Azure, and there's basic load balancers and standard load balancers. And if you want to load balance, if you want to have a public-facing load balancer that load balances to multiple availability zones, you have to use a standard load balancer with a standard public IP. The default is, if you're just going through this kind of wizard, it's just basic and dynamic, which for this particular lab is fine. But a little bit later, we'll go through a different lab with a public-facing load balancer with multiple availability zones, and we will choose standard. And it won't ask us if we want a static IP address because the only option is with a static IP address. All right, there we go. And that's now what shows up in the IP address. Finally, the last step is review and create. There should be a validation step that runs. I would say this is usually somewhere between 5 and 10 seconds. I've had a couple of issues over the last year or so where there was some work being done with the marketplace images and it failed validation, not because of anything I had done, but some work that Microsoft was doing. Fortunately, that didn't happen today. Everything says validation passed. There is a review screen. I can see some of the elements of the parameters that I entered. I'm comfortable with all of those, so I'm going to go ahead and click create. And it has been submitted for deployment. I'm going to go ahead and click the deployment in progress. And we will see this deployment, which is still in progress. And if we wait, we will see more and more resources show up in this list as being deployed. Right now, I can see a little green check mark next to the protected VNet. So the virtual network has been deployed. Oh, more stuff just added to the list. I see a NIC number 1 and a NIC number 2 that looks like they were created. I see that we have a public IP address that was created, and I also see little updates to NIC 1. So this is actually the creation of the two network interfaces right here, but then there were some updates to them. This is going to go on for a couple of minutes. It is not an instantaneous process. I would say we could safely pause for 3 or 4 minutes, and it probably will finish somewhere around there. So what I'm going to do is go ahead and pause the video, and I will unpause it when it looks like it's complete. Now, if you're doing this on your own, if you're going through the video and following along on your own, keep an eye on the little alarm bell notification up here, deployment in progress. When it's done, it'll mark that it's been completed here. So I'm going to go ahead and just leave that be. I'm going to pause the video, and we will return. For you, it'll be instantaneously, but we will return in a few minutes when this is done. I'd say it's been about 3 or 4 minutes, and we are coming back to our video now. Our deployment is complete. So I'm on the same screen that I was on just a moment ago, but it says your deployment is complete. And if we go looking over here under the little alarm bell icon there, little notification icon, it says deployment succeeded. Yep, there we go. That's what we were hoping for. If I wanted to see all of the resources that have been deployed, one of the easiest things that I could do is go to the resource group. Everything was deployed in this group. Think of this group as a container. That's how I like to conceptualize it. There's the SX Lab group. And within that group, there will be some resources. I see the VNet that I created, the virtual network. I see a public IP address that was deployed, SXFGT Lab1. Now, that's a virtual machine. There I see some route tables, say 2 route tables that were deployed, a network security group. Network security groups are stateful filtering mechanisms built into Microsoft Azure. They are basically layer 3 and layer 4 filtering control. So we can filter what traffic can go into an instance or what traffic can go out of an instance. There are 2 virtual network interfaces. I see SXFGT Lab1 NIC 0, SXFGT Lab1 NIC 1. So this VM has 2 network interfaces. I can also see there's another subnet. So routing table, subnet routing table. So I have an inside subnet routing table and a public subnet routing table. And then my last 2 resources, these disk resources, these are resources for the virtual machine. Every virtual machine that you deploy generally has at least one virtual disk that usually contains its operating system. Any data inside of that virtual machine is within a virtual disk. If you've ever used vSphere or KVM, you probably have seen that virtual machines have virtual disk files that contain their data. In vSphere or ESXi, it's called a VMDK file. In Hyper-V, it's called a VHD file. Certainly every hypervisor has some type of container file for the disk of a VM. Well, that's what these 2 files are. They're the disks of this virtual machine. Now, going to the resource group and looking at the list of resources is an easy way to see all of these resources, but it's not necessarily the most logical grouping of them. Many resources, if I go back to this menu, I can see go into like a particular type of resource, like virtual machines. I go to virtual machines and click on that, and I should see, there we go, the Lab SXFGT Lab1 FortiGate virtual machine. If I click on it, I'll see more information about it. Here's its name, the SKU for it. Over here on the right side, the private IP address. Oh, well, let's talk about this private IP address. When you see the word private IP address, that's not necessarily an IP address in the private or inside subnet. That really means the IP address within the VNet. What IP address does it have within this VNet? So within the public facing subnet, it has this IP address 10.0.0.4. It also has this public IP address associated with it, 40.122.207.126. That's the public IP address. So that's the IP address that sits on the outside of the VNet. We'll go and revisit that again here in just a moment. This particular VM should have 2 network interfaces attached to it, and I believe if we look at it here in a moment, we'll find that it does. So as we scroll down the list here, there's underneath settings, there's networking. And here we find there are actually 2 NICs attached to this. The first NIC is NIC 0. That's what plugs into the public subnet that we saw just a second ago. And if I had any doubts about this, here's my NIC 0 resource, and it has the IP address 10.0.0.4. And if I click over here, this is my NIC 1 resource, and it has the IP address 10.01.4. And for each one of these NICs, I can see which subnet it's plugged into. This one's plugged into the public-facing subnet. This one's plugged into the inside subnet, or I would have been able to draw that conclusion by looking at the IP address. 10.0.1.0 was the inside network, 10.0.0 was the public side network. Below that, I can see the network security group that's been applied to this network, to this virtual NIC. And both virtual NICs, well, let's just double check here. NIC 0 is using this network security group, SXFGT Lab1 random string NSG. And let's go look to see if the other NIC is using the same one. Oops, there we go. SXFGT, yeah, that looks like that. That's the same network security group. So both NICs have the same network security group attached to them or applied to them. And when I look at this, inbound port rules, I see that priority 100. So a little bit about network security groups, because if you've tried AWS, this is going to look a little bit different. These rules that you configure have a priority. This is basically like a sequence number, and rules are processed by that number. So priority 100 is before 65,000, 65,000 is before 65,001, 65,500. That's the last rule in the list, so that's processed last. It is like a firewall policy list. You are looking for matching criteria, and the first match wins. So priority 100, this first rule in the list, says any port, any protocol, any source, any destination, allow it. Well, let me tell you, my friends, that's going to match all traffic. So no traffic is ever going to go any farther than that. So any traffic at all is going to be allowed to go into this NIC. And it's stateful, so replies would be allowed. And then for an outbound rule, we have an allow all outbound at the very top of the list, and any traffic is going to be allowed out of this NIC. And since this is a FortiGate, that's reasonably appropriate, right? We can create firewall policies that can filter things out. And we might choose not to do this. We might choose to be more limiting about what we let go into the FortiGate, so the FortiGate doesn't have to process traffic that we know would never be allowed anyway. However, this particular ARM template is very open in terms of what it allows to enter the FortiGate. We now need to create firewall policy to choose what the FortiGate is going to choose to process and accept in policy. Very good. That's there. Disks, we could go and see the disks that we saw earlier. I'm reasonably comfortable with the disks. I don't think there's too much more that we need to see here. Let's go take a look at our VNet that was created. So I can click that little 3-line menu icon and go down to virtual networks. There we go. Should be one VNet that was created for us, the FortiGate protected VNet. If we look over here to the side, let's scoot this over. A little bit easier to, there we go. The 10.0.0.0/16 CIDR for that. Let's click on it. Similar to the virtual machine object that we created on the virtual machine resource, when you click on it, you get information about it. For instance, what is currently plugged into this VNet? Well, there are two things plugged into this VNet. Here are the two virtual NICs that are plugged into it right now. That's in the overview. And we can see that's a network interface with 10.0.0.4, that's a network interface with 10.0.1.4, which subnets they plug into. If we wanted to see a list of subnets, we just continue down the list here, and we'll find subnets. There is the inside subnet, 10.0.10/24, the public-facing subnet, 10.0.0/24. We can see how many of those IPs are currently available. Remember, the first three IPs are never available, .1, .2, .3. Of course, the subnet IP is not available, so the .0 IP would not be available. But let's just leave FortiGates for a while and think about how subnetting works, right? We all learned subnetting at some point. The subnet IP we don't assign to hosts, and the broadcast IP we don't assign to hosts. So the .0 IP and the .255 IP, we wouldn't have those anyway. In addition to that, the .1 IP, or the first available IP, is for the intrinsic router, the second IP is for DNS, and the third one is reserved. So the first IP address that was available was .4, and that's what the FortiGate was assigned in both of those subnets, which leaves you 250 more addresses that you could add into those subnets. Very good. Let's go ahead and click on a subnet. Let's click on the inside subnet. That should be an interesting one. If we click on the inside subnet and look through its information, we see things like the address range. Yeah, nothing really surprising there. Network security group, you can apply a network security group to a subnet, filter all the traffic that's allowed inside of the subnet. It's a similar, the network security group is the same type of security group that we saw applied to an individual host, but now it applies to all the traffic within that subnet. Well, it's not set to any right now, it's set to none. Routing table. By default, all of the subnets know how to route to each other, and they will simply route directly to each other. By creating a different routing table, a user-defined routing table, and adding routes to it, we can manipulate the built-in default routes where things just route directly to each other. And we can choose to create routing table entries where, for instance, in order to route out to the internet, anything in the inside subnet has to go through the FortiGate. So there is a routing table called SX FGT Lab1 inside subnet routes alphanumeric string, which was chosen automatically. And that should have a routing table entry that says to get to the internet, go through the FortiGate. To examine those routes, I cannot do that here. From this particular menu, all I can do is choose which routing table that subnet would use. And if you see none, that means it's just using the built-in routes, which only knows how to route within that VNet. So what I'd like to do is go find that routing table. If I go looking under resource groups, I can go to the SX Lab resource group. Remember that the resource group is like a container. It contains all of the resources. So I have a list of resources down here. I only want to see the routing tables. So if this was a really long list, I might want to choose to filter my output. So instead of looking at all resources, I can go to type. I can say only show me the resources where the type is equal to, and I'll uncheck select all, and I'll say route table. Wow, and then I'll hit OK. Very good. Uncheck select all, and then choose route table. All right, apply. Yes, here are our two routing tables, the inside subnet routing table and the public facing subnet routing table. Very good, let's look at the inside subnet routing table. I have two routes inside of this routing table. One route says to go to the internet, the to internet route, that's the name of the route. If the destination is 0000/0, then go to 10.0.1.4. 10.0.1.4 is the IP address of the FortiGate. So inside my protected subnet or my inside subnet, this is the route that says if you want to go to the internet, go to the FortiGate. I also have a route that says if you want to go to the public facing subnet, the 10.0.0/24, go to the FortiGate. If I added more subnets to this VNet, I could add more route table entries like this. For instance, if I had a 10.0.10, oh, I do have a 10.0.10. If I had a 10.0.20 subnet, I could create a route that said to go to 10.0.20/24, go to the FortiGate. To go to 10.0.30/24, go to the FortiGate. I could have a routing table entry. Let's say, for instance, the FortiGate had an IPsec VPN that it was using to connect back to on-prem. And on the other side of that IPsec was 192.168.1.0 network. I could create a route that said to go to 192.168.1.0/24, go to the FortiGate, go to 10.0.1.4. All of those things are appropriate. If it is within the VNet and I don't create a user-defined route to overroute it, it will route directly. So without this second route to public-facing subnet, if something in the 10.0.1.0 network wanted to talk to something in the 10.0.0 network, it simply would have routed directly. Now this makes it go through the FortiGate so it can be processed by the FortiGate's firewall policy. Down below that, we see which subnet, I didn't mean to click on it, I just meant to highlight it. Let's go back here, here we go. Which subnet is this applied to? It's only applied to the inside subnet. And when I clicked on the subnet a few minutes ago, we saw there was a drop down and I could choose different routing table. You can only have one routing table applied to a subnet. If we go looking down through the list here at things like configuration or routes, let's go to routes. I could add more routes. I mentioned that I could add more routes. This is where you add them. Pretty easy to add. So I could go in here and say to IPsec or to VPN on-prem, call it whatever I wanted. I could say, if it was going to 192.168.1.0/24, send it to the virtual appliance. Now, this is, by the way, that's something that we didn't see in AWS. For all of you who already know AWS, we actually tell it a virtual appliance, and it's, well, which virtual appliance? What's the next hop? 10.0. Well, let's learn to type first. 10.0.1.4 I don't have to do a /24 there. Here we go. There's my next hop. That would tell it to be able to get to the 192.168.1.0 network, go to 10.0.1.4. I was like, wow, I'm sorry, I apologize for the pause there. I was trying to figure out what it didn't like about my my route. It didn't like my spaces. To VPN route. There we go. Now my OK button is lit up. There we go. Now I don't actually need this route. I'll go ahead and click OK and save it, and then I'll just delete it. So now up in the top right-hand corner, we have a notification saying that it's adding a route. And it won't show up in the list here really until this has been completed. So I'll give it, there we go. So I'll give it 30 seconds to complete. I'll click on routes again over here to, let's get rid of this. There it is, to VPN route. Let's go ahead and delete that route. See the little 3-dot context menu on the outside there, around the right side? I can delete that route. All right, and it's going to delete that, and I'll let that go ahead and finish deleting on its own. Let's go up to the breadcrumb bar at the bottom, dashboard, resource groups, SX Lab. Let's go back to the SX Lab resource group because there were 2 routing tables in here. Let's go look at the public-facing subnet routing table. There's only one route in this routing table. It's the to inside subnet, 10.0.10/24. So if traffic goes to the 10.0.0 subnet and it's destined for 10.0.10/24, its next hop is the FortiGate. The FortiGate's interface plugged into that subnet, the 10.0.0.4 subnet. You'll notice that there's no internet route here. There's no 0000/0 go to this route. This is a little different than perhaps AWS that you saw has a little bit of functionality. AWS is something called the Internet Gateway. This is a little bit different than that. Everything in the VNet by default does know how to route out to the internet. So even on the inside subnet, before I added the 0000/0 route that goes through the FortiGate, or before our ARM template created that route, because I actually didn't create it, ARM template did. Before that, everything in that VNet would have been able to go out to the internet directly, because everything can go outbound and get source netted to a pool of Azure IPs. Network security groups can filter that, can stop it, but from a routing standpoint, if you don't see a route to the internet, it knows how to get to the internet. What IP address it gets source netted to depends upon the instance and whether or not it has a public IP associated with it. If it has a public IP, like our FortiGate does, then it will get source netted to the public IP address as it goes out to the internet. If it doesn't have a public IP address associated with it, there's a pool of public IPs that are automatically used from Azure. So any VM that you create by default has outbound access to the internet. That doesn't mean you can reach it from the internet. To go to it, you always have to have a public IP. So to go back to diagram here, let's just move this down and out of the way. Where's that lab diagram we were working on just a minute ago? Sorry, this is actually from an earlier course. We don't need this anymore, and we don't need this anymore. Yeah, here it is. Let's pull this over here. Here we are. So we've got a routing table. We've got a routing table for this inside network that says to go to 0.0.0/0, go here. And to go to 10.0.0/24, also go here. On the public subnet, change my ink color here to purple. There we are. On the public subnet, there is a route that says to go to 10.0.1.0/24, go here. There is not a route that says this, /0. If this route is not explicitly created, any VM will automatically be able to go outbound to the internet. Now, in the case of our Windows VM down at the bottom that's going to be inside of the inside subnet, when it tries to go outbound to the internet, it's going to go through the FortiGate. by virtue of this route right here that's on that routing table. When it goes outbound to the internet, it'll go to the FortiGate. The FortiGate will process that against policy and then go out to the internet itself. When it goes out to the internet, it'll put that packet out on the public-facing subnet, and the built-in route to get out to the internet will enable it to do so. And when it does go out to the internet, let's change back to purple, it's going to get source netted to that public IP. So if somebody does pings 8888 and 888 replies to public IP, that goes back there. All right, let's go ahead and erase all of our drawings. Go back to a regular mouse pointer. Continue our example. Well, that's a pretty good overview of what the ARM template deployed for us. There were some elements that we needed that weren't in that ARM template, like there was a Windows server in the inside subnet. We need to go deploy a Windows server. Let's go work on that. Get this out of the way here. Let's go create a resource, please. Let's just search for Windows Server. I might have several things show up on the list here. Marketplace probably has a lot of things that says Windows Server. I did have a lot of things show up, but fortunately at the very beginning of the list was this right here, Windows Server. If, for instance, I had a lot of things show up and I couldn't find this very easily, you can always come in here to Publisher and say, just show me the things that are from Microsoft. Clicked it twice. Let's go back there. Microsoft. Show me the things that are from Microsoft. And that should cut down your list, and we should be able to find an entry that says just Windows Server, because as you see, there's lots of things that say Windows Server in them. All right, we'll choose that, and we will choose a specific version of Windows Server. I'm going to choose Windows Server 2019 Data Center with a small disk. I do not need a very large disk for what we're going to work on. This is going to be as small of a footprint for Windows as I can probably use. So we'll create this. I'm going to use a pay-as-you-go version. I will put this in the SX Lab resource group that I already have created. This is going to need a name. I'm going to call it SX Windows Server SRVR. There we are. It's going to go in the US Central region. Now you do have to be a little careful here. It's easy to pick a different region. Remember, your VNet is in Central US right now. So if I picked a different region, as I tried to do networking, I would find there was no VNet for it, and it would prompt me to create a new VNet. I don't want to create a new VNet, so I'll just say Central US. Ask me what image I want. Well, I've already chosen an image, DS1 V2. I have done this lab using B1Ss before and F1Ss, these little VMs with 1 or 2 gigs of RAM, and B1S is a lot cheaper. So if you're doing this on your own, you might choose a B1S. It's 1 CPU, 1 gig of RAM. But running Windows Server 2019 with 1 gig of RAM is a little bit slow, a little painful. It's kind of a small virtual machine for Windows Server. So I'm going to go ahead and bite the bullet and choose DS1 V2. I won't be running this for very long, so that should ultimately cut down my cost. And I'll give it a username. Admin. Password. At the bottom, it should ask me some questions about inbound port rules. And I'm going to choose allow selected ports. I'm going to actually add multiple ports at this time so that later in later labs, when I need port 80 and port 443, the inbound port rules already has it open. Very good. Let's go ahead and hit next for disks. Shouldn't be anything that I need to change there. So I'm going to go hit next for networking. If I've done my job correctly, my existing VNet should already be here, FortiGate protected VNet. If there's no existing VNet, then I would need to go back to the basics tab. I almost certainly have deployed this into the wrong region. or I deployed my VNet into a different region earlier, but that's usually why you don't see a VNet, because there's no VNet in the region that you're trying to deploy to. We're going to put this in the inside subnet. All right, very good. I feel pretty good about that. I could give this VM its own public IP, but I want to access it through the FortiGate, so it doesn't need its own public IP. We'll choose none. Then I've got a network security group, just the basic security group should be fine. Allow selected ports, HTTP, HTTPS, and RDP, that should be okay. Turn accelerated networking off, it's already off. And no, I don't need a load balancer. When I go through management, it's just going to let me know that if I want boot diagnostics enabled, it's going to need a managed storage account, which I do have. If I didn't need boot diagnostics, if you mouse over this, troubleshooting boot failures. So if I didn't want it to use any storage, then I could disable this altogether. This isn't going to exist very long. I'm not worried about a storage cost associated with that. Let's just go ahead and say advanced. Nothing that I need in here. I'm not going to add any tags at this point. So there'll be a validation step when I go to review and create. I should see running final validation again. There we go. Typically less than 10 seconds, and it should validate. I should be able to scroll down to the bottom and don't see anything new for me to do. Click create. Once again, we have a deployment running, and we should see over on the notification, yeah, there we go, submitting deployment. And then it should begin deploying, and it will invariably take a couple of minutes. Not quite as long as, say, the FortiGate ARM template took. Remember, the FortiGate ARM template had several things that it needed to deploy. It needed to deploy a VNet, NICs, subnets, lots of route tables, lots of different things to deploy. This will be much simpler, so it won't take quite as long, but it's not instantaneous either. While we're working on it, though, while it's doing that deployment, we don't have to sit idly. We can go and maybe bring up the GUI for the FortiGate. So let's go find our VMs, virtual machines, go find the FortiGate and go find its public IP address. SXFGT Lab1, I'll click on it and its public IP should show up in its list of information here. Yeah, there we go, public IP address. I'll just highlight that, copy it, and paste it. Here we are, advanced, proceed. Now in AWS, the default admin password is admin and the instance ID. In Azure, you actually set the password, the username and password during the deployment. So the only real question is, did I forget the password that I set? Nope, doesn't look like I forgot it. Just let that come up. Let's go take a look at our network interfaces. Network interfaces. Should be two network interfaces, one in the 10.0.0 network, one in the 10.0.1 network. Indeed, 10.0.0.4, 10.0.1.4. Let's go ahead and edit these and add some aliases to them, make them a little bit easier to look at when we're creating firewall policy in just a second. Alias public. You can see the IP address is statically set. Port number 2. Alias inside. There are some static routes that were created automatically on the image at deployment. There's a default static route, a 0000/0 static route that says to get to 0000/0, go out of port 1 and go to the intrinsic router. And so this is making traffic go out the public subnet to go to the internet. There is another route that says to get to anything else in the 10.0 network, go out port 2. And then there's a 168 route in here. This is a route, I believe it exists to handle Azure traffic for some type of metadata that Azure's doing, and that goes out the public. So that's really for talking to Azure. But this one is kind of interesting. So what we're really doing here is saying, if any traffic is going to flow through this FortiGate to other subnets in the same VNet, they're going to flow through this inside subnet. Let me make a little drawing for you, kind of talk about what I mean by that. Here we have VNet. And we have this public subnet. That's what port 1 is connected to. Here's my FortiGate. And we have this inside subnet. What if I wanted more subnets inside? I could have a database inside subnet. Maybe that's the .3.0/24. I could have a web subnet. For the sake of it, I'll write it down here. Maybe that's the 4.0/24. Some other type of application subnet. Let's put an A in front of that. Application subnet. Maybe that's the 5.0/24. So I've got the 3.0, the 4.0, and the 5.0. They're all part of this 10.0.0/16. The FortiGate only has two interfaces on it. It has an interface in the 10.0.0/24, the 10.0.1.0/24. That's supposed to be a /24. Did a terrible job there. All right, let's go ahead and change colors for a moment. Change pen color to black. I would create subnet routing tables for each of these, right? And for each of them, I could create a routing table entry that said to go to, well, certainly I would create one that says to go to the internet, 000/0, go to this IP address right here, 10.0.1.4. Also, I could tell these subnets to go to anything else in the same VNet, go to 10.0.1.4. So as a database server sent something towards the web server, as he sent it towards his subnet, which means it would go to his intrinsic router, the intrinsic router would understand, well, let me open the routing table and send it here. And the FortiGate could process that through policy. The policy would be policy that said inbound on port number 2 and outbound on port number 2. And if it passed policy, it would go back out and go to the web server because it would go to 10.0.40/24. And there's a routing table entry to support that. It says, well, all of the 10.0 networks are actually available on the 10.0.1.1, so it could go back out and reach that. This allows us to do east to west segmentation within the same VNet, which is something that AWS cannot do with a VPC. Likewise, if the application subnet, we'll draw this traffic in a slightly different color here, about red, there we go. If something came out of an application server, so we had a server inside this application subnet, and it was destined to 10.0.30, so it's on 10.0.30, as the packet came out into the subnet would read its routing table, right? We have over there that routing table, and it would say, oh, this is destined for 10.0.30, I need to send it to that interface, because that's what the routing table entry tells me to do. And it would go and get evaluated against FortiGate firewall policy, and assuming firewall policy accepted it, it would go back out the same interface and go to the database servers. Now, that's how we would use that 10.0/16 route. That's not part of our lab example here, and in fact, I don't think we have any labs that are quite that complex. But I do want to point out that this can be done, and done relatively simply, especially if you're accustomed to the Amazon Web Services world. Because in the Amazon Web Services world, within a single VPC, this isn't actually possible. You have to deploy something else called Transit Gateway if you want to do east to west segmentation. And Transit Gateway, unfortunately, is outside of the scope of what we talk about in this course, and certainly in the Azure videos. But it is something that is available to do that. So if you wanted to do that in AWS, fear not, there is a solution, and it's not that difficult, but it is a little bit more cumbersome than simply deploying a single VNet the way we can in Azure. So kudos to you, Microsoft. You guys have made an easy way to do this. Let's go ahead and erase all of that. All right, well, we've got our public network, our private network, we've got our static routes. All of those were bootstrapped in through our ARM template deployment. So some of these things I might have to actually go and configure. Let's go take a look and create a VIP. Let's give ourselves a regular mouse pointer first, normal mouse pointer. Policies and objects, there we go. VIPs. Let's create a VIP, virtual IP. Let's call this the Windows RDP VIP. This is for traffic coming in on the public interface, which is, if I put my mouse over it, right, that's the 10.0.0.4/24. Yes, it is. So here I'll just say 10.0.0.4. And the mapped, this is where it's going to go to the Windows IP address on the inside subnet. And I don't actually know what that is yet. I actually have a pretty good idea what it's going to be, but I don't know for sure because Windows was still deploying. So let's go take a look at Windows. If I go and look at my notification bar, it says my Windows deployment succeeded. So I should be able to go and see what my Windows server is. Now, before I go over and click on this, I'll tell you a little bit about Microsoft Azure. Microsoft Azure assigns IP addresses in numerical order. The FortiGate was the first host in each subnet, so it got .4. The second host in a subnet will get .5. The third host in the subnet will get .6, .7, .8, .9. That's given out in order. And the only reason that it would skip that order is if I chose not to auto-assign an IP. You can create a resource and tell it, nope, I want you to use this specific IP. But if you just let it do it, it will assign them in order. So when I go over to Windows Server, it should be 10.0.1.5. So let's go take a look at Windows Server, and we'll look over on the right side. Yep, there it is, 10.0.1.5. So let's make that our mapped IP address on the VIP. Very good. I don't want all of the traffic to 10.0.0.4 to be included in the VIP, just the RDP traffic. So I'll do this. Now I need a firewall policy for that VIP. That's what we'll create next. The only firewall policy created by default is the intrinsic implied deny policy. I said intrinsic, sorry about that, the implicit deny. So we'll create a new policy. For traffic coming in on the public interface, going through the inside interface, where the source is really anybody in the world. The destination is the Windows VIP. The service is RDP. I'll accept the traffic, put it in flow-based mode. I don't need to source NAT this. I'm going to go ahead and tell it to log all sessions. Click OK. Or click OK again. There we go. All right, well, let's see, I've gotten what I need there. Let's go ahead and pull up RDP and try to hit the public IP address, MSTSC. So this is the same public IP that I'm bringing up the console with, the FortiGate console. I'll just Control-C, get the HTTPS out of here. We don't need that. Get that little / out of there. We don't need that. Click Connect. If I did my job right, it should prompt me and ask me for a username and password. Oops, I think it did. It might just be in the background there. There we go. It did. It just needed a moment. Here we are. Use a different account. Administrator. Oh, that's not what it is. I didn't make this administrator. I made this FortiAdmin. Well, the inbound policy worked out okay. I am going to, I'm going to wait for Windows to finish starting up there. There we go. Yes, that's fine. I'm going to let Server Manager open. Get that out of there. I'm going to go to local server. I'm going to turn off the Internet Explorer Enhanced Security configuration because I want this Windows system to be able to try to browse the internet. And with Enhanced Security configuration turned on, Internet Explorer will continually ask me to prompt, are you sure you want to let this go out? And I just don't like to get prompted, so I'm going to turn it off. Click OK. And I don't really need Server Manager to be open anymore, so I'll close that. And we'll go and open up Internet Explorer. While we're waiting for it, there we go, it finally came up. Well, if I've done my job right, I should not be able to go to Google. I'm proving the negative here. I'm proving that I cannot go to Google. Inbound access works because I have a firewall policy that it's allowing inbound access through the VIP. Outbound access is not working. Now, a moment ago, you might have heard me say, you might remember I said, all instances have outbound access to the internet by default. True, by default, they all can route directly out to the internet. But I have a routing table entry here that says if traffic goes to 0000/0, send it to the FortiGate. And my FortiGate does not have a firewall policy allowing outbound access to the internet. So that is why this is currently not responding, because the FortiGate is matching it to the implicit deny policy and not letting it out. If I go taking a look at my logs right now, I will take a look and just verify that my inbound traffic is coming in. Yep, there we go. It's coming in through the Windows Server RDP policy. And that's my current source IP address, 66.212.42.225. There we go. I have two different ISPs. That looks like my wired ISP. I also have a 4G ISP. When I use my 4G, it's usually a 166 IP address. So I must be getting there through my wired connection right now. Well, very good. So if I want that system to be able to browse out to the internet, I'm going to need to create an outbound policy. Now what we've done so far is what's in lab number 1 in the Azure Labs. Lab number 2 is pretty short, so I'm going to go ahead and add it to the same video that we're already working on. Let's just take a quick look over here, pull it over. And what I'm going to do to support creating that outbound policy, let's just grab a pen. I'm going to create a Fabric connector. The Fabric connector talks to the Azure public cloud. It allows me to have an API connection to the public cloud so that I can do things like create a dynamic address object. The dynamic address object can automatically include all of the any of the IP addresses within my VNet. And I can be as specific as I want to here. I can say automatically have an address object that filters and includes anybody in the inside subnet, or includes any Windows servers, or includes any, and there's lots of different filters that I can set up here. And if I don't like the filters that are built in, I can even use tags. Tags are extra pieces of information about a resource object. So I could tag all of my web servers with the word web. And then I could create a dynamic address object that said only include the IP addresses for resources that are tagged with the word web. There's lots of different options there. Once I have the Fabric connector in place, I can create that dynamic address object, and then I can add that dynamic address object to an outgoing policy. And that's what Lab 2 is going to be. So we're going to go ahead and do that now. And let's put myself back on a regular mouse clicker. Pull this over here. Very good. My first step is, well, let's just go look at this first. Let's go to Fabric Connectors, say create a new connector, and say Microsoft Azure Connector. I need authenticating information for my tenant in Azure, my account in Azure, if you will. So I need to go create that authentication mechanism, that credential. So what I'm going to do is leave that right there, go back over to Azure, click on the menu item, go to Azure Active Directory. Good. And there'll be some items that I have to create and some items that I simply need to jot down. So let me get Notepad open because there's going to be a few things over here I actually need. Here we are. So one of the things that I'm going to need is my tenant ID. I love that it's got this little copy to clipboard icon. That's really handy. Let's say Azure tenant ID. Very good. I'll need that. Then I'm going to need to create what is effectively a user account for it. So I'm going to go down to app registrations. Since this is a programmatic user, not a human being user, if you will, I'll go down to app registrations, choose new registration. SX, I'm going to give it what is effectively a username. It's called a service principal. Think of it like a service account name. That's a good way to think about it. SX FortiGate Fabric Connector. And I'm going to go ahead and jot that down real quick. There we go. I'm going to choose to register that. We'll need the application's ID. Actually, I think that I'll need that. I actually don't think I'll need the name that I just created for it. I think I'll need this. Application client ID. Very good. Tenant ID is 125E. That sounds correct. Oh, come back here. I did not, I guess I clicked a link on accident. I meant to scroll down. On the left side, certificate and secrets. And I need to create a client secret. This is sort of like my password. That's the easiest kind of thing to think about it. It's sort of like a password. All right. I can give this some kind of description. So I'll say Fabric connector. I'll tell it to expire in a year, although I really don't need it to last that long. This part right here, this value, that's my secret. Let's copy that down. That one is important. I won't be able to get to that again. That's the last time I'll get to see that in plain text. I can always delete it and create a new secret, but I won't be able to see that secret again. So let's just write over here that this is the secret. So I've got my tenant ID, I've got my client ID, and I've got my secret. And how I like to conceptualize this is my existence on Azure, my tenant on Azure, my account on Azure, if you will, my subscription, if you'd like to think about it that way. That's me on Azure. This is effectively what I like to think of as a user ID on my tenant, and this is what I like to think about as sort of a password on that tenant. That's the easiest way to sort of conceptualize that. Very good. Last little bit here, there is actually a separate subscription ID. Let's go over two things that I need to be able to do here. I'll do this first. Actually, come to think of it, no, this isn't on the screen. I need to go to the resource groups. Here we go, resource groups. Go to the SX Lab group. And get the subscription ID. Don't think I need this. in the current version though, but we'll see in a moment. And finally, role assignments. It's under Identity and Access Management. I'm going to add a role assignment. I'm going to give the owner role, which is a very broad role. If I were doing this in a production environment, I would probably choose a role that only had certain rights available to it. But in this case, I'm going to give it the owner role. And I'm going to assign it to Azure Service Principal. So we've got Service Principal in there. I should be able to type in what I named this a moment ago. No, I didn't jot down what I named it. Sign up SX40. Ah, there it is. Thank goodness. I typed in S and it gave me everything that started with an S. SX40 Fabric Connector. Save that. Add the role assignment. So effectively, I'm giving the Fabric Connector service principal, the service account, rights to this group. While we're waiting on that to finish, I'm going to go back to Azure Active Directory. Just to double check my work real quick. SX FortiGate Fabric Connector. Okay, very good. That's the one that I just created. September 10th. Oops, I can go back there now. Oh no, I clicked on it, so now I'm looking at it. Okay, very good. All the same, very good. SX FortiGate Fabric Connector. I just had a moment of doubt in myself where I was wondering what I named that. If I assigned the role to the correct service registration, and I did, so I feel pretty good about that. We should be all right. Well, now I should be able to go back to the FortiGate, which has logged me out. I just timed out. I should go back to that Fabric Connector creation screen. Create an Azure Fabric Connector. All right, name that. Give it my tenant ID. Control C. Give it my client ID. Control C. Give it my client secret. In 6.2, those are the only three things that you absolutely have to have in there. Just click little. I'm glad I clicked that. I think I typed it in wrong, or I think I copied and pasted the wrong one. Let's go back to the secret. Try this again. Actually, no, I think I'm looking at what I pasted. I bet that's not the actual secret. If you guys, I don't know if anybody caught this while I was making the video, but look at my client ID and my client secret. It seems pretty unlikely to me that those are going to be the exact same string. So I think it's fair to say I goofed up. So since I goofed up, let's go create a new secret. I mentioned earlier, you can't see that secret again. It's gone in the wind. Let's go to the list of certificates and secrets. Let's go ahead and I can see that it started in B9 dot. That's all I can see. Let's delete that one. Are you sure? Yes, I'm sure. I don't have any applications that are using it. Say new client secret, 1 year. I'm just going to give it another description, hit add. Very good. Here we are. Let's try this again. I'm going to hit the little copy to clipboard. I'm going to paste it into Notepad. This time I'm going to look at it. Last time I didn't even look. There it is. That looks a little better. Very good. Control C, come back to the FortiGate, Control V. Very good. I'm going to go ahead and click OK. We'll come back to what resource path has and some other things in there. And if I click refresh, hey, got a little green up arrow icon. Now you'll find some documentation from us, especially as you look back at 6.0 and older versions, that tells you to get some of the other pieces of information like the subscription ID or the name of a resource group, because you can filter down a connector to only get information from a single subscription. These are now optional characteristics. You don't have to have them in there, but I did grab them. So I'll go ahead and pull this out, copy and paste. And then it asks me, well, resources from which group? And I could have it only pull resources from the SX Lab group. I'm gonna go ahead and leave those off, but that is what those are, why those are there. And that's why some documentation will tell you to note down your subscription ID, because it used to be that was one of the forced parameters in here. I'm gonna go ahead and click OK. I'm going to go down to policy and objects and addresses. Let's get this out of here. We don't need this anymore. We're going to create a new address object. Call it Azure Lab. And for type, we'll say dynamic. And then subtype will be Fabric Connector address. And then it'll ask, which SDN connector do you want to use? Well, I've only got one configured. It's called Azure. What kind of IP address do you want me to go and get? Do you want me to go get the private IP address, which means the IP address within the VNet? Or do you want me to go get the public IP address, which would be the outside IP? So for instance, SX FGT Lab1, the FortiGate does indeed have an outside IP. If I say private, we'll see I can say, give me all the IP addresses for resources in Central US. Give me all the private IP addresses for resources in SX Lab. I can tell it to get me all of the IP addresses that are on network interfaces assigned that particular security group, the Windows Server Security Group, or that security group, the FortiGate Security Group. I can say, get me all the addresses of the DS1v2 size VMs or the standard F1S VMs, all of them of a particular subscription. I can even list individual virtual machines. Lots of different options in here. I also mentioned that if you don't like the built-in filters, you can tag resources inside of Azure and then tell your dynamic address object to only include things with a particular tag. So let's go ahead and create a new filter. The filter says if the tag.FortiGate equals lab. So if there is a field called FortiGate and it has the value lab within it, automatically include that resource in the list of private IPs. I'll go ahead and click OK. Now, when I go look at this address object right now, I'm going to have a red bang on it. And basically the problem is going to be I don't actually have any resources currently tagged that way. So even if I had chose something that was valid, it would have a red bang on it for a couple of minutes while it worked, well, a couple of minutes, for about 10 or 15 seconds, I would say, while it went out and got the IP addresses from Azure. But this one's not going to be able to resolve. I don't have anything tagged with that. So what I'm going to do is I'm going to go back to the Azure console and I'm going to tag a resource. We're going to go find the Windows server in the list of VMs. We're going to click on it. We're going to add a tag to it. Let's go see what that looks like. We'll go list of virtual machines, Windows Server VM. On the right side, there'll be tags, and there aren't any. Click here to add tags. And we'll create a tag named FortiGate with a value of lab. This should make this VM included in our list of resources in that filter. We'll click Save. I'll wait for that process to finish up there. Successfully done. Now I see the tags lab. Let's go back to the FortiGate. I'm just going to click on this and see if I can get it to refresh. It's no longer got a red bang on it. And I see that it's got, Azure resolves to 10.004, 10.014, 10.015. That is perhaps more than I expected it to resolve to. I didn't expect it to resolve to all of those things. I expected it to resolve to 10.015, by the way. Oh, well, look at that. The reason that it resolved to all of those things, it actually would have gotten rid of the red bang earlier if I'd have just waited 10 seconds and refreshed it. Because as it turns out, I created that new filter, but I didn't actually use it. I left it filtered to resource group. I must have misclicked. Well, that was a mistake on my part. Let's go down to, I think it is this one is the one that I just created. Filter name, although it looks different. I'm going to create this again. Make sure I type this in correctly because it doesn't have a very specific format that it has to follow. Tag.FortiGate equals lab, all lowercase. Let me just compare that. The tag name is FortiGate and it is lab, all lowercase. Very good. That's what I was looking for. User customized. And this time I'll click on the darn thing. By the way, when it was set to the group, it just included all of the IP addresses for everything in that group, which was 10.014, 10.004, 10.015. All of them were created. So let's go ahead and put my mouse over it. There we go. It resolves to 10.015 and only 10.015. So that worked well, with the exception of the human goof up, which I did, which was, I'm going to take a guess and say I never finished creating that filter. That's probably what I did. If you went and replayed the video, I bet you I went through and I typed it in and I just never clicked OK or saved it, some variation of that. Well, now that I've got this dynamic address object, if I created 10 more Windows instances and I tagged them all with lab, with FortiGate equals lab, then they would automatically be included with this address object, which means I could create a firewall policy one time and it would automatically include all of those systems. So let's create a firewall policy. We'll say Windows Server outgoing. Incoming interface, if it comes in on the inside interface, and it's trying to route out to the public side interface, and the source is the dynamic address object, and the destination is really anything else. I'm only going to allow HTTP and HTTPS. Accept it. On the outbound side, source NAT it, and it's going to source NAT to the 10.004 IP. But as it goes outbound, the 10.004 NIC gets source NATed eventually to the public IP address that Azure has assigned to the FortiGate, 40.122.207.126. The same IP address that I'm actually using to reach the FortiGate, the same IP address that I'm actually using to RDP into the Windows instance. So source NAT outbound, log all sessions, click OK. Very good. Let's go back to Windows, see how we did. Well, there you have it. I had an error, and by the time I clicked OK to the error, I can get out. Let's just go to Google and ask Google, what is my IP? And we see that as I actually go out to the internet sees me as the public IP address that's assigned to the FortiGate. That's what the internet believes is talking. Well, very good. That should take care of us. Let's just go back to the FortiGate, and I suppose we can go into logs, the forward traffic log, and just maintain that we really are going through the outbound policy. There it is, Windows Server outgoing. Indeed, we are. Well, we're going to take this environment that we created with Lab1 and Lab2, and we're going to use it in Lab number 3. We're going to deploy a FortiWeb in it. But we've been going for a little while, and I want to break this up into multiple videos. So we're going to go ahead and pause here, and I hope I get to see everyone in the Lab 3 Azure video coming up next.